Now next comes the parallel connection. In parallel connection, let us say this is my voltage source, this is my element 1 with impedance Z1, and this is my element 2 with impedance Z2. Now if you see, these two impedances are connected in a loop, and this loop consists only of these two impedances and not any other element. So if two elements are to be connected in a parallel, then they must be a part of a loop which does not contain any other element except these two elements. Now here the criteria is the voltage is same across both the elements, okay? Because suppose I considered it to be a ground, the voltage at this point will be V, because if you move from here minus to plus V, there is a jump of voltage V. At this point the voltage will be V, and the voltage at this point will also be V, because there is no voltage drop, there is no resistance in between, so there is no drop. The voltage at this point is also V, here is also V, and at this point also voltage will be V, because there is no resistance in between them, there will be no drop. So you can see here the voltage across VZ1 is equals to voltage across VZ2. What I mean to say is the voltage across this element and the voltage across this element is same, which is equals to V, which is equal to supply voltage V, okay? Let us say the supply current is I, and the current in this branch is I1, and the current in this branch is I2. Now if you apply the KCL, from KCL we will get I is equals to I1 plus I2, okay? Incoming is equals to outgoing. So from here you can say that current I1 is equals to V by Z1, okay? Because the voltage across this element is V minus 0, that is equals to V. So V by Z1, so we can write here I1 is equals to V by Z1 plus I2 is equals to V by Z2. And this supply current I is equals to V by Z equivalent, okay? V by Z equivalent. So we can write here that supply current I is equals to V by Z equivalent. From here we will get 1 by Z equivalent is equals to 1 by Z1 plus 1 by Z2. Why? Because V will get cancelled from both the sides. So you can see that if two elements are in parallel, then this relation holds good, okay? 1 by Z equivalent equals to 1 by Z1 plus Z2. Now in case of resistance, Z1 is equals to R1 and Z2 is equals to R2, okay? Then there R equivalent will be 1 by R equivalent is equals to 1 by R1 plus R2. What about inductor? In case of inductor, Z1 is equals to SL1 and Z2 is equals to SL2, because in Laplace domain, okay? So 1 by SL equivalent is equals to 1 by SL1 plus 1 by SL2. From here we will get 1 by L equivalent is equals to 1 by L1 plus 1 by L2. Why? Because S will get cancelled from both the sides, okay? For capacitance, Z1 is equals to 1 by SC1, Z2 is equals to 1 by SC2. 1 upon 1 by SC equivalent is equals to 1 upon 1 by SC1, 1 upon SC2. This part will go to numerator, okay? So from here we will get C equivalent is equals to C1 plus C2, because S will get cancelled from both the sides. This C1 will get to the numerator and this C2 will get also in numerator. So this relation we will get, okay? C equivalent is equal to C1 plus C2. So if you see, resistor and inductor follow same principle in series and parallel addition. But capacitance follow the opposite principle. That is, the rule for series and parallel are just opposite for the case of capacitance versus resistance and inductance. Is it fine? Now let us summarize this. If two resistance are in parallel, their R equivalent will be 1 by R equivalent is equals to 1 by R1 plus 1 by R2. If you further simplify this, R equivalent is equals to R1 R2 by R1 plus R2. You have to remember this formula, okay? First multiplication, then addition, okay? Similarly, in case of inductor, same rule. L equivalent will be L1 L2 by L1 plus L2. For the case of capacitance, if two capacitors are in parallel, C equivalent is equals to C1 plus C2, okay? Now similarly, as we said that two current source cannot be in series. Similarly, two voltage source cannot be in parallel. Let us see. Suppose these two current source are in parallel, okay? So we can apply the KCL here. The current in this branch will be 15 ampere, because 5 plus 10 is equals to 15 ampere. So this is a valid. Two current source can be in parallel, okay? By means of KCL, we can convert into a single current source. We can replace these two current source by a single current source of value 15 ampere, okay? But in case of voltage source, two voltage source cannot be in parallel. Why? Suppose you connect this point to the ground, okay? The voltage here is 0. If you travel along this path, minus to plus, the voltage at this point will be 10 volt. Travel from this side, 0, minus to plus 5 volt. You can see that at the same point, we are getting two different voltages. One is 10 volt and one is 5 volt. This is not possible. At the same point, we cannot have two different voltages. Okay? Or you can see like that also. If you apply KVL in a loop, it will not come out to be 0. Okay? Apply plus 10 minus 5 is equals to 5. It is not coming out to be 0. It means KVL is also not satisfied. That is why two voltage source cannot be in parallel. But two current source can be in parallel. Okay? Similarly, two current source cannot be in series, but two voltage source can be in series. Okay?